Howdy, and welcome back. So last time we talked about how atomic vectors are vectors. So number one, a vector is an ordered collection of objects in R, ordered collection of elements. And an atomic vector means that all of the elements have the same class, the same type in R. And then we said that we can bend that rule a little bit and create an atomic vector so that everything in that, all of the elements of that vector have the same type, but we can add a label to the outside of it called an attribute. And the attributes could be a different type of information than what we had originally in the vector itself. And this allows us to have a little bit of flexibility in terms of creating these atomic objects. Now, what we want to talk about in this portion of the lesson is named subsetting. So before we had given an example that if I wanted to find the number of months that I had been employed at the hospital, then I could take the eighth element of that ID card vector and multiply it by 12. But we said, okay, well, number one, there's a problem here because the 2.1 had been promoted from double information or numeric information to character information. So we can't multiply it by 12 anyway, because it's non-numeric. But then what if someone was coming behind us and reading our code and was saying, well, I don't understand what that means. So let me scroll back up and show you what I'm talking about. Let's see. So right here, if I tried to take my ID vector and I say, okay, well, here's my ID vector. I want you to go inside the vector and get, that's the single square bracket operator, says go inside the vector and get something. I want you to get the piece of information in the eighth position and then multiply it by 12. Now we understand that since we just created this vector, we understand that the piece of information in the eighth position is the item or element called time employed, and it should have the value 2.1. Now, in this case, it's going to have a character vector, but let's say that we fix that and we've figured out a way to get this to be numeric information, and we want to multiply it by 12. Well, the issue is we're still writing this code right here, and it's kind of challenging to read. Somebody that would come behind us and be like, okay, well, what's the eighth element of this thing and why am I multiplying it by 12? Now, so I want you to think about this. I want you to think about this piece of code right here versus, I'm going to write the exact same code, but I'm going to use name subsetting instead, time employed. Okay. Now, when I look at this bit of code, this is easier to read. It's easier to understand. It says, I'm getting the time employed out of this object called Dr. Gabriel, and I'm multiplying it by 12. Well, now we're like, okay, well, realistically, maybe this should have been called years employed or something, and then it would be abundantly clear that I'm finding the months that I've been employed, because anytime I see something that says years employed times 12, I'm getting months. But this, regardless, even if I had said time employed instead of years employed, this is much easier to understand what's going on than this. Just by itself, I don't know what the 8 is. That doesn't help me. If I come back to this code in 6 months, I would much rather see this piece of code than this piece of code, because I'm going to be able to figure out what's going on in this line of code without running it. It's like, okay, it looks like I'm trying to find how long in months that I've been employed. Whereas this piece of code, I'm like, I don't remember what 8 was. Why am I multiplying it by 12? What's going on? Is there I don't know. Is this like because is this my height and I'm trying to get it from feet to inches and I'm multiplying by 12? I don't know. So it's really difficult to read this code and know exactly what's going on. But this code, it's much easier to look at it and say, I understand what's going on. Okay. So we're going to get rid of all of this, but this is getting at the idea of named subsetting. So when you subset a vector, if you say, give me that piece right there, most of the time you don't actually want to count out the information. You don't want to say, I want the thing in the fifth position. You want to say, I want let's see. So if we go back to our bakery example, in the top row in the fifth position, if that is the like guava and cheese tequeño, then you say, I want one guava and cheese tequeño. So you're pointing exactly, you're not saying, I want one of the things in the fifth position in the bakery case. Because what if the next week they change the order in which the elements are supplied in the bakery case? Then you say, oh, I want the fifth thing. Well, now the fifth thing is, I don't know, a chicken empanada or something. But if you say, I want one guava and cheese tequeño, that it just happens to be in the fifth position, that's fine. Even if I come back a week later, or if I come back a month later, if I come back 2 years later, and I say, give me one guava and cheese tequeño, it doesn't matter where in the case it is. It doesn't matter where in the vector that element is. I'm still getting the right piece of information. And this actually happens a lot more than you might realize, particularly with, and I'm going to kind of throw the CDC under the bus here for a second. We were working with CDC data related to the COVID pandemic, and it was about like every other week, maybe once a month, they would change the order of the columns. Sometimes the columns got shuffled around, sometimes they were in a totally different position or whatever. And so if we had said, give me the information in the fifth column of this spreadsheet or the fifth column of this rectangular data, well, one week we might be getting population, another week we might be getting the county FIPS code. Another week we might be getting, like, who knows, right? But if we had said every single time, I don't want to just like, don't give me the fifth column, but give me the column that is named this, that is named number of positive COVID tests per 12 to 64-year-old population or whatever. Then no matter what, every single time I'm getting what I ask for. And if I say, give me this column, and it doesn't exist because they changed the name, then it's easier for me for it to trigger an error. And it tells me like, hey, you asked for this column. You're trying to get this column out of this data set that doesn't exist anymore. You need to look at this. But if you just said, give me the fifth column, unless the data set shrinks down to 4 columns, which is highly unlikely because these things have hundreds of columns, if you say just give me the fifth column, it's always going to have a fifth column. It just might not always be the information that you're looking for. So named setting is important. All right. So if we said, all right, we've got our ages integer vector that was 31, 29, 27, 25, 23, and 21, and then we added names to it. So again, we can, this is names, if you remember, this is an attribute. So we're attaching an attribute to this atomic integer vector, and now it has names. So this time, instead of just saying, give me the first name in the list, I can be specific and ask for who it is that I'm looking for. So I say, give me Gabriel's age. Now, this power, and I do say power because, as I mentioned earlier with the CDC spreadsheets, you absolutely want to be using named subsetting. This power does come with a weakness. Unlike positional subsetting, where you could say, give me the first element, or you could just put a negative sign in front of it and say, do not give me everything except for the first element. You cannot use the negative sign with named subsetting, not with base R. Whenever we learn a little bit more with dplyr, and that's in a couple of lessons, then we'll learn how to work with this negative sign to make it a little bit easier. But for now, it's going to give you an error, and it's going to say that there's an invalid argument to a unary operator. Now, I want you to take a little bit of time and think about what this error means. So if binary means it takes 2 arguments, unary means it takes 1 argument. So the operator here that only takes 1 argument is this minus sign. The minus sign does not work with character information. So character information is an invalid argument to this operator, the operator being the minus sign. And it happens to be a unary operator because the minus sign only takes in 1 argument here. So, and that's what this paragraph is talking about here. So it's worth kind of reading through and understanding. And I will take it just a kind of a side detour here. One of the reasons that R can be challenging for a lot of people to learn is because the errors don't make sense. You would have rather this said, hey, the minus sign doesn't work with named subsetting, because that's actually what you were trying to do. You were trying to take a named atomic vector and subset to say, remove the element called Gabriel. I want to return everything except for Gabriel. So I'm going to use the minus sign and say, give me everything except for Gabriel. So it would make sense if the error said, hey, you can't use the minus sign for negative positional subset. Like you can't use the minus sign for named negative positional subsetting. It doesn't work. But instead we get this, which if I hadn't explained that to you, would have been very, very complicated. And you'd be like, what is a unary operator? What's the invalid argument? Well, honestly, what's an op? I mean, you might even be asking, what's an operator? So just understand that R can be challenging simply because a lot of times the errors are a little bit cryptic. So just be patient. If you get stuck, ask for help. Google errors. It's often helpful to do that. Okay, so I think we're going to, I have an exercise right here. Extract the ages of the oldest and youngest siblings, but do that using named subsetting rather than position or logical subsetting. Okay, and this is where we're going to pause it for now. So see you shortly.